Hello, my name is Dipesh Biswakarma and I am from Ethical 34 batch. My Softerica ID is 240081, and today in this video I will show the exploitation process of Coursework2 binary. The program typically contains two critical vulnerability. The one is format string vulnerability and another is stack based buffer overflow. I was able to get to the root at access by plotting a chain exploitation along with the given vulnerabilities. So before getting started, let's check the few of the binary file details. So for that, I will use file cw2 command. Here we can see this is 64-bit by executable file which has been compiled for x86-64 architecture, and this is dynamically linked. Next command, let's check ldd file name. So here we can see the path of the uh, libc address, and another we will check the protection that has been enabled to the given binary file. Here we can see it is pi enabled, so the addresses will get randomized in every run. Next we have nx enabled, so this means it prevents code execution on the stack level. Next we have stack canary found. So canary found means it protects against the buffer overflow, but since there is a vulnerability in the program, we will be able to get to the root access. Next we have a full railroad. Railroad is full means GOT cannot be write, it has only the read access. Now next we will move towards the Gitra and see the static analysis. Here under the admin module we have a modify user privilege function which is vulnerable, and next we have a modify existing module which is under the teacher module and which also has a vulnerable function. Now let's go to the modify user privilege. Here if we see here um, printf, so if you check over here, this printf is vulnerable. Why it is vulnerable? Because generally printf expects fixed format string, but in the code user input, the local underscore 68 user input acts as a format string. So therefore if user enters format symbols such as %x, %p to read and percentage n to write memory, it can leak sensitive address, and that's what happens along with the exploitation process. Next, if we go to the modify existing module, here we can see here under the read function, if you check on the read function, there is no comparison made. For instance, if we go above here and see the local underscore 278, here it is defined, so it has the 616 byte. This means 616 byte buffer is allocated on the stack, means it can safely store the most 616 bytes. But in this read section, if we see here, it copies data from the standard input. So whatever input we gave, it could be of more than 16 characters or bytes. It can be more than 616 bytes. So there is no validation, and that data buffer size is allocated which should be less than 616. So when data buffer size is greater than 616, the extra data spills outside of the buffer, and that caused the critical vulnerability exposed. Right after the buffer, there is the program sensitive values and addresses, such as information need to return from function to the program, security check, which we have seen over here. Although these all are enabled, due to the misconfiguration in the code level, the program is vulnerable. So let's validate the format string vulnerability, and for that let's go to the terminal. Now let's run the program normally. So for now, since it is under the admin module, we'll log in as an admin. For the password, I'll copy it from the code only. Okay, login successful. Now we have modify user privileges, which function is vulnerable. So here already the username was created, which was the base, and I entered that only. So here this is the payload that will leak the address. So if you check here, two of the addresses has been leaked. So if you see here 0 into 7f, so always the libc address start with 0x7f. So this is the standard for the libc address. So this is the libc address, and since this address have 00 at the end, this is the canary value. So these two sensitive data are leaked from this particular payload given. Now let's close this and open GDP in the binary in GDP. Disassemble, modify existing module. So this is the vulnerable function. If you check over here in 144, okay, line number 144, it calls read@pilt function. So the function which was vulnerable and we discussed over here, that particular line calls of the this particular function. Now let's set breakpoint at two different places. Modify underscore existing plus 159. Next it will be modify underscore existing module plus 144, which is the function that calls, which is the line which that calls the function read, which is vulnerable. Now two breakpoint has been set. Let's start the program, continue. Now we need to sign in as a teacher, because this particular vulnerability is associated or linked with the teacher module. TACHR teacher. Let's go to the code section. I'll copy down the password, paste it. Authentication successful. So when we are modifying the module, the particular read function will be called, and we can hence verify the stack buffer flow vulnerability to okay 1. So here you can see over here this buffer address has been leaked. Now let's examine this buffer address. Okay, here we can see two of the addresses has been leaked over here. So this this address over here is the canary address, and here you can see the return address. So as we have already discussed, when the bytes are above the declared, or let's say defined stack level, or above that, when it goes, it leak the return address, which is prone to the critical vulnerability. Now since both of the vulnerability we have validated, let's move towards the code section, and I'll brief this down. So this basically first part is simply binary and architecture setup, this is the since we are running in the Docker, so this is the local host and port is 1337. This is how we connect to the remote server under GDB or just running the binary locally. So these are the offset defined here. So one is libc offset and other is buffer to return address. The difference offset is mentioned here. First, this will register a normal user, that is the base I mentioned, and password will be the base as well. Now this is all what we have done one by one just before. Log in as an admin, then enter the username which is the base, and we'll go give the payload. This will leak two of the address, that is canary value and the libc address. Next, we'll check over here. So this process is just we are getting the addresses which is leaked, and this next we log in as a teacher, and this is the calculations which has been done. This is Rob Gazette calculation part. So after we get the available or required leaks, it logs in as a teacher. This module reads user input into a fixed size stack buffer flow without a proper bond checking, which leads to the stack based buffer overflow exploitation. Now this is the payload, and which is used for further process. And finally we get the root cell. So I would like to show by accessing the root cell. Okay, let me run the Docker first. Okay. So Docker is running. Now let's. So basically why we are not giving your IP and port is because we have already explicitly mentioned here. We can directly do this. If you check here, so process similar process which we did one by one: created user, login, admin login, then format string leak by giving the input, then canary leak, libc address also has been leaked, which will be used while making the ROP gadget. So teacher login, buffer interflow, and switching to the interactive mode. If we check ID, it's root. Who am I for the verification, ls-la. So this is how all the exploit was conducted. Thank you for watching.